The periodic table is a list of all the known elements. It is organized by increasing atomic number. There are two main groups on the periodic table, metals and nonmetals. The left side of the table contains elements with the greatest metallic properties, and as you move from the left to the right, the elements become less metallic, with the far right side of the table consisting of nonmetals. The elements in the middle of the table are called transition metals because they are changed from metallic properties to non-metallic properties. A small group whose members touch the zigzag line are called metalloids because they have both metallic and non-metallic properties. The table is also arranged in vertical columns called groups, or families, and horizontal rows called periods. Each arrangement is significant. The elements in each vertical column or group have similar properties. Group 1, elements all have the electron in their outer shells. This gives them similar properties. Group 2, elements all have 2 electrons in their outer shells. This also gives them similar properties. Not all of the groups, however, hold true for this pattern. The elements in the first period or row all have 1 shell. The elements in period 2 all have 2 shells. The elements in period 3 have 3 shells, and so on. There are a number of major groups with similar properties, and I'll go ahead and talk with you about most of them. Hydrogen is, this element does not match the properties of any other group, so it stands alone. So you'll see it in the top left-hand corner. It is placed above group 1, but is not part of that group. It is very reactive. It's a colorless gas at room temperature. And notice it only has 1 valence electron. So that's why also they put it above group 1. Now group 1 are called the alkali metals, and they start with lithium and go down all the way to francium. And these metals are extremely reactive and are never found in nature in their pure form. They are silver colored and shiny. Their density is extremely low so that they are soft enough to be cut with a knife. And you guys will see this in my next demonstration when we look at lithium compared to sodium in their reaction. Notice that lithium and sodium both have 1 valence electron along with hydrogen. So you can see in the outer shell there is only 1. And then also here a picture of the 2, lithium and sodium. You'll again see them tomorrow. Notice that they are silver and that they are shiny. Alkaline earth metals are in group 2. They're slightly less reactive than alkali metals. They're silver colored and more dense than alkali metals. Notice that beryllium and magnesium have 2 valence electrons, so there are 2 electrons in the outer shell. And you'll start to see that pattern as we go across. So remember when we talked about ions, and we want to form that octet rule in where we want 8 electrons total to become a noble gas. These guys want to lose the 2 rather than gain the 6 because it's easier. Notice a picture of beryllium and magnesium as well. They're shiny, and they also have that lustrous color to them. So we'll see that these are also have metal characteristics, and as we go to the right, you'll see how the shapes and colors of the different elements change. Then we move on to our transition metals. Transition metals is this huge block in the center. And what we see for transition metals is that these metals have a moderate range of reactivity and a wide range of properties. In general, they are shiny and good conductors of heat and electricity. They also have a higher density and melting points than group 1 and 2. Typically, there are only 1 or 2 outer level electrons, but you can also see when we get into forming compounds that some can have +3 charges or +4 charges. Notice too that the 3 that I gave you, manganese, yttrium, and copper, all are shiny, all have that metallic property, and again, they're good conductors of heat and electricity. When we get into metallic bonds, we'll talk about why that is. Now, the group of elements that we deal with less are the lanthanides and the actinides. The lanthanides and the actinides are also transition metals, but they're taken out of the periodic table at the bottom because the table is so wide with them in it. So as you can see, that orangish colored block is the lanthanide actinide series, and they're removed and placed below so that so it's easier on the eyes when looking at the periodic table. The elements in each of these 2 periods share many properties. The lanthanides are shiny and reactive. The actinides are all radioactive and are therefore unstable. Elements 95 through 103 do not exist in nature but have been manufactured in the lab. That brings us to our next group, to boron, the boron group. It contains one metalloid and 4 metals. They are reactive. Aluminum is in this group and is also the most abundant metal in the Earth's crust. Notice if we look at the Lewis dot structure that we see that there are 3 electrons in its outer shell. Again, if we want to follow that octet rule, we either want to gain 5 or lose those 3, and we know that losing 3 is going to be easier, so most of these have a +3 charge. Notice boron. Boron is our only metalloid in this group. Notice it does have a similar properties with metals, but what you'll find out is that it has properties that also don't align with a metal status, but more of a non-metal status. So that's why it becomes is classified as a metalloid. And aluminum, you guys have dealt with on a regular basis. Aluminum has that that metal characteristic. That brings us next to our to group 14, which is our carbon group. This contains 1 nonmetal, 2 metalloids, and 2 metals. There is varied reactivity in this group, but what we do see is that all of them have 4 electrons, 4 valence electrons in their outer shell. So here's where we reach that tipping point again, remembering back to our ions lecture, is that it either wants to gain 4 or lose 4, and since it's easier, neither one of those are easier, it can have a +4 or a -4 charge. Carbon is our only nonmetal. Notice the picture that I gave you is a picture of a diamond, which is made up of carbon. There are varying forms of carbon, diamond being one, charcoal being another. And then a picture of silicone, which is a metalloid as well, has a shiny characteristic as a metal, but will also have characteristics of a nonmetal, thus classifying it as a metalloid. That brings us to group 13, which is nitrogen group. Nitrogen group has 5 valence electrons, so this is where we get over to our anions, because what happens to fill that octet rule, we want to gain 3 electrons rather than lose those 5 because it's easier, so all of these are going to have a -3 charge. With the nitrogen group, it does contain 2 nonmetals and 2 metalloids and 1 metal. There is varied reactivity due to that. Notice the pictures of nitrogen and phosphorus. Nitrogen, that's liquid nitrogen that's shown a picture of, and then phosphorus this is red phosphorus, and both of them have nonmetal characteristics. The next group is the oxygen group. This contains 3 nonmetals, 1 metalloid, and 1 metal. It is a reactive group. If you could look at the Lewis dot structures that I provided you of oxygen and sulfur, there are 6 valence electrons, so it wants to gain 2 to complete the 8, that octet rule. And the pictures I showed you, though, oxygen is liquid oxygen, which has a blue color, and then sulfur has the yellow color, and that's what that rotten egg smell comes from, sulfur. So these 2 are the nonmetals in this group. The group that has fluorine, chlorine, bromine, and iodine are halogens, and they are all nonmetals. They are very reactive. They are poor conductors of heat and electricity, and they tend to form salts with water. So for example, sodium chloride, you guys are familiar with, but any of the halogens in our ionic compounds, which we'll talk about later, is very common. Notice there are 7 electrons in our Lewis dot structure, so we only want to gain 1 electron rather than lose those 7, giving us a -1 charge. I gave you a picture of fluorine being bubbled through because fluorine is typically a gas, and then chlorine is also a gas, and that's in a glass container. And chlorine typically has a green shade to it. Chlorine is very poisonous, and most others. The only other that's non-gas in the halogens is bromine, and then iodine can vary depending on the temperature, around room temperature. The last group that we are going to be talking about are the noble gases. These are completely unreactive, and they're unreactive because if we look at them, they have a complete set of valence electrons. Helium's the only exception to the octet rule because it is in that row 1. Remember, when we want to look at how many electrons the elements need, it's the number of elements in the row. So since helium, there are only 2 elements within that first row, it only wants 2 electrons to be stable. Krypton, however, has 8 elements within that row, so it's going to have 8 valence electrons, thus completing its octet and thus being non-reactive. All are colorless, odorless gases at room temperature, all found in Earth's atmosphere in small amounts. All right, guys, this is the first lecture. Hope to talk to you soon.